Hello everyone, I am back because I finally got the new motor drivers. These are the 100 amp dual channel motor drivers from China. It will replace the IBT2s. I don't know if I've actually shown the stacks off with them outside of the box, but basically I desoldered all the connections that went to the motors because those came off. Those are all right here. Those come off and split right here to go into the IBT2s, and I won't need that anymore because now all of the motors will have individuals. Come on, into there, and right next to that Chinese writing you can see B and A, and then positive and negative. So that first set of 2 terminals is the power in and out. Second set of terminals is for motor A. Third set is for motor B. And then they will get wired up to the Arduino. And they will actually, let's see here. They actually get wired up like such. So they're a 5-pin right here, down here. So I got 5-pin ribbons for those. I'm gonna solder those up and pin them out and then test them. I actually got 5 of these motor controllers. The other 3 are up there next to the IBT2s that I had set aside for the 6 DOF. Those are the 3 other 100 amp motor drivers next to the 6 IBT2s I had set aside for the 6 DOF. That I was going to build the power box out of this guy. But I want to finish the 4 DOF before I do that. So the Chinese motor drivers came in today, and I've been working to get these removed and then get these guys wired up and test them. So that's kind of the next step. And then wire them up inside of this box. I'm thinking that I'm actually, instead of having them mounted down here onto this plywood, I'm actually going to mount them to this face sheet plywood right here. They'll actually come off of this sheet metal. I'll have 2 little wings essentially that I'll rivet onto there. They'll come off the sheet metal and essentially sit halfway in between the fans. The heat sinks basically are positioned nicely for the fans to get a lot of cooling. And that way when I take this apart and I lift this up, I don't have to take all of the pins out of the Arduinos to be able to do that. I can just unscrew this and take this face off, and the motor drivers and Arduinos will come with it like they do here. The only thing that will be wired to it will be these here, which will be the shortest leads. I'll make sure of that. And then the leads that'll come up and go to the motors there. And then the only other thing will be the positive and negatives and the potentiometer wires that go into the Arduinos. So still might not, I might lengthen those, I don't know, lifting the front face up and having to like pick it up and turn it so I can see inside there is a pain. But if the motor drivers are connected onto here, then I won't need to actually get down below to get to the screws, which is the main reason why I had to take this front face off anyway. So also, since the wiring is much more simplified for these 2, it's basically, since one of these will control 2 motors, so I'll basically have like instead of surge and left on this side and then right and traction loss over here, I'll probably put surge and traction loss over here and then right and left over here, and then connect everything up. The power, I can remove this power block here, this terminal block, because instead of having to go from these power wires, these 2 would go into one, these 2 would go into one, and these 2 would go into one of the terminals, and then it would come off from one lead back into here to where the power leads would go to the power shutoff button. Instead of having to do all that conversion, I can take this out, and then this lead will go into this power motor driver. This lead will go into this motor driver, and then just 2 of these 4 negative leads will need to go over, 1 to each. So I can reduce 2 of these leads, basically cut off these double links, have them go over there, remove this power block. These 2 leads will go over to each one of the 2 motor drivers, and then hook everything back up. But first step is I'm going to solder up wires and pins, so that way I can plug it in and test all 5 of the motor drivers, both channels, both directions on 24 volt. And I'd like to do it with a load, with the power clamp on there, see how much they're pulling. Do it with this the bucket with 40 pounds of sand weights in there. But that brings us back over to the motion simulator. The motion simulator has kind of a new setup, which is I got so tired of having to pull the throttle on to put it on and pull it off whenever I got in and out of the sim that I basically would never ever mount the throttle. And I loved the fact that when I had a door, I didn't ever have to worry about that. I would just open the door to get the throttle out of the way to get in, and then close it, and the throttle's right back in position where it needs to be. So I went and got the door that I had manufactured previously when there was a giant cage that was sitting around this. And I basically cut it off right here. This piece used to go up and have a cutout. Actually, I think it went up here and then had a cutout, or cut out this way for the wind sim, and then came up and met like somewhere up here. So I cut that off there and measured it to basically be the same height as the windowsill for, you know, any general American car that I would drive. So that way I can rest my elbow on this while driving. But the main reason why I never went through with the door, everything else about the door is the exact same. The mounting points, I never cut those off. And I never had to modify anything from the door except for that piece up there and then doing this piece here. But the main reason why I never kept the door and modified it previously when I took the cage off is because I was worried about the door latch system. I needed something that would not rattle. I needed the door to not rattle when the sim was in motion, because I just didn't want to deal with that noise. And I wanted it to look and feel like a car door. Like, I kind of, you know, if you've gone through this much to make the sim look good and you actually built the door, then you need to make it look and feel like a door. So I basically had to build a door handle, and that's what this mechanism is here. So we take you around this side. Actually, this side probably doesn't have much room. Focus, there we go. So I reused the gate hinge that I had on the door. Let's see, there we go. I had on the door back when it was a wood sim. So I reused that gate hinge and just bolted the bolt piece onto aluminum, and then welded that to the frame. Then bolted the latch piece onto a piece of aluminum here, welded that onto the frame, and then just bent a rod that goes through here into an S shape. Put return springs on this end of it, and then for up here I had to manufacture my own handle, so I just had this flat aluminum stock, and I just cut out like these kind of, not really triangle, kind of triangle pieces, but I cut the top end of the triangle off, and then flat piece right here to give it kind of that wedge shaped, and then just cut little tabs off. and drilled holes through them, put the threaded rod through there, and kind of mounted everything, and then welded the tabs to this plate, and then welded the triangles to this plate to give it all kind of in line and level, so that way it feels good and it has good actuation. And then the rod, the S-shaped rod, goes through there. Hole I drilled the bottom side there. Basically, when you lift the handle, it pulls up on the latch, which releases it, right? Opens the door, and then the door will swing open to there. And in order to stop it, let's go around this way. In order to stop it so it doesn't just keep swinging open, I just welded a bit on the steel frame there. That was like a kind of temporary piece for a proof of concept, but it works, and I'll probably weld something better on right before I paint the frame, which I'm going to do right after I test and verify that the new motor drivers work. So I had these rubber pieces that are mounted onto a bolt. Like they already had, sorry about that, stopped the recording, but they already had a bolt mounted onto the back side of them. So drilled holes to mount those, and these basically, when you close the door, they basically just hold it against the frame and stop that vibration, you know, because they're like rubber isolating mounts essentially. So got a door built for this version. Before I paint, I'm gonna grind these, and then I'm gonna cut plates to weld on here so I can cap all these tubes off. Let's clean that look up. The last thing that I'm going to do is I actually did buy the diamond plate for that, and that's over there, right there. So that diamond plate is pretty thin because the thicker stuff is expensive. So that's like super thin diamond plate. So I'm not going to be able to like cut it and weld it. So the plan is I'm going to modify the footwell. I basically don't like how it's angled up right there because I can't put the rudder pedals all the way forward, which is a bigger deal now because the honeycomb Charlies are a lot thicker than the CH products that I had. So I need them to go further back, and that 2 or 3 inches right there would be a big help. So I'm basically going to cut those off and have those bars just go straight out and then meet up with the frame. And then after I do that, then I can put the diamond plate in, and I'm going to bend it to where that bend just goes straight up and hopefully meets all the way to the top, but there might be a gap. And then the edges, I'm just going to bend out a bit, and then I'll have to cut off the excess. But that's basically the plan for that, is just to bend it into the footwell shape that it needs to be. And because I don't think I'll be able to weld it very well with my spool gun because it's very, very thin. So that is the last step, and I'm going to rivet that into the footwell, but I will do that after I paint everything, because I'm not going to paint everything when I have the diamond plate, because I'm not going to paint the diamond plate. So next steps are get the motor drivers wired up and tested, test all 5 of them, both channels, hopefully with weight, make sure everything's good, build up the box, put the box back, test everything with the new motor drivers in the box for a couple days, a week, whatever. I want to get good tests. I want like longer tests to make sure that it can handle that, and then strip everything down and paint it. and then reassemble everything and retest it, and that will be that for the 4 DOF rig, and I can start on the 6 DOF. All right, that's the update. Talk to you guys later. Hey, come here. Come here. Why you want to go inside?